right, once again I've left some area off on the right for comments. We'll see how that works as we work into different software. I'm going to go File, New here. And this is going to be a general real quick 10-minute discussion on where you move on from once you kind of have the general circle, the unit circle. So cancel. Alright, so let me draw it up here and remember all these different ways where you move on from once you know that this is, and this is, and this is 0, 0, and this is 1, 0, and this is 0, 1, and you remember, of course, these out here. What you might realize pretty quickly, square root of 2 over 2, square root of 2 over 2, 1 over 2, the square root of 3 over 2. You might realize that these are flipped. This becomes the square root of 3 over 2, and this becomes 1/2. You might also realize that this over here are positive and positive. These over here are negative and positive. These over here are negative and negative. And these over here are positive and negative. You know, all silicon life forms take chemistry for positivity. Where do you move on from here? Once you get all that, you start to realize things like the cosine of 30 equals the sine of 60, right? You remember, of course, that cosine is the first, and sine is the second, and tangent is the sine over the cosine. There's where you move on. You don't stay stagnant in any of this stuff. You move on to the fact that if you know the angle of the unit circle, then you also know the area. You know that the area is half the angle. If the angle is in radians, the area of the unit circle is 1/2 the angle. And you can start playing around with that. You move on later from the fact that if you double the area of a circle, you take the ratio of the radiuses, radius 1 to radius 2, you square it and you multiply it by the area of the unit circle, pi. So you can use this kind of concept of if something is twice as big or twice as small in terms of radii or dimension or diameter, that it's going to be either 4 times bigger or 4 times smaller. You then move on to the sphere, which has a volume equal to pi. The volume of a sphere is 4/3 pi r cubed, and the area, surface equals 4 pi r squared. You keep building on this. You keep building on it until you really do look at this knowledge of the base circle as secondary, but you look at the knowledge of the circle as primary. I'm going to go to a new page and finally then tell you where this goes for some, not for all. In other words, some being your second semester. And that is shifting over from this knowledge of the circle, x squared plus y squared equals r squared, and then shifting to this knowledge of the Cartesian system to a spherical system where you know that x, the value of x, is equal to r times the cosine of theta. And the value of y equals r times the sine of theta, which means that another way to write this up, if you think about it, is x squared plus y squared equals r squared, or you could write this r squared cosine squared plus r squared sine squared equals r squared. You could divide everything out and you would get cosine squared plus sine squared equals 1. And you know this is true. And so you'll see later on as you start shifting from a formula for a circle that looks like this: x minus h squared plus y minus k squared equals r squared, where h and k are the coordinates of the center of the circle. You could be able to get to a format where you'll start to see things like this: r squared plus 4 cosine of theta plus 2 sine of theta equals 15. And eventually, maybe not recognize it, but realize that is a shifted circle in the Cartesian coordinate system. So this fascination with the circle is not just a pure fascination. It ties you into spherical coordinates. Spherical coordinates, which is really what I would call natural math for me. With Cartesian math, natural math being spherical, in other words, what's behind you and how far away from it, natural math, and then 3, what we're going to call battleship math. That is matrices. Oh, Peanut, you need to go outside? Okay. Or you. Come on, Peanut. Go outside? I know. You're a good dog. You're going here. I'll explain later where I went, but for now, that's the answer, or that's the discussion. Thanks for listening.